Okay. Hi everyone, welcome back. Today we're going to look at aqueous solutions again. This time our concentration focus is going to be percent by mass. So percent by mass, well, you kind of get the idea. It's a percentage in respect. Oh my god. Hi everyone, welcome back. Today we're going to look at concentration, but this time we're going to look at percent by mass. So percent by mass essentially gives you an idea of what this is already about. It represents the amount of solute in a solution through the percentages that its mass makes out of the entire mass of the solution. So the percent by mass of a solution is really just the mass of the solute divided by the total mass of the solution times 100. It's pretty straightforward. It is just a percentage, so there's one part out of a whole, but this time in the context of mass. So let's see some examples of where percent by mass can be applied. So our first example reads, a solution of potassium nitrate dissolved in water is 15% potassium nitrate by mass. So how many grams of solute are present in 275 grams of solution? In this case, we know that our solution is 15% potassium nitrate. Well, this is just the mass of the solute, which is potassium nitrate, divided by the total mass of solution, 275 grams. So, pretty straightforward question here. All we're doing is looking for the mass of the solute, aka the mass of potassium nitrate. So then the mass of potassium nitrate would just be the product of 15% of 275. So our solution would contain 41.3 grams of potassium nitrate. So this is your pretty standard question, essentially identifying what mass of a solute is present if you know the percent composition of the solution in respect to mass. So look at a couple more examples of how we can adjust our equation and find a couple of other things using percent by mass. So here we're told a 12% hydrochloric acid solution contains 14.9 grams of solute. So our first question here is what is the mass of the solution? So in this case we know it's a 12% by mass solution of hydrochloric acid. But now we know that it contains 14.9 grams of solute, which is our hydrochloric acid, and we're looking for the mass of this entire solution. So, just rearranging, we get that the mass of our solution is just going to be the mass of the solute, 14.9 grams, divided by our 12%. And we see that our mass of solution is 124 grams. So then in part B, we're asked if the density of the solution is 1.06 grams per milliliter, what is the molarity of the solution? So with these types of problems, it's always good to just lay out, well, what are you being asked to find? We're being asked to find the molarity, and molarity is moles of solute over liters of the solution. So if we're going to answer this question, we need two parts. We need to know the moles of the solute and the volume of the solution. Well, fortunately, we know the mass of the solute. We have 14.9 grams of hydrochloric acid. So we'll take our mass of hydrochloric acid and convert that into moles, dividing by its molar mass. So 14.9 grams of hydrochloric acid gives us 0.409 moles of hydrochloric acid. So we're already halfway there. Now all that's left is to find the volume of the solution. In part A, we found the mass of the solution, which is great but not very helpful right now because we're looking for a volume. What is helpful is the fact that we are told the density of the solution. So we know that density is just mass over volume. And since we're looking for a volume, we can use the density and the mass that we found in part A to find the volume. Volume would just be mass divided by density, which in our case becomes 124 grams divided by 1.06 grams per milliliter. So our solution would have a volume of 131 milliliters. Shit. Ugh. Damn it. So now all that's left is just to find the volume of the solution. Well, in part A, we're told the mass of the solution, and that's not very helpful. But in part B, we're given the density. This is what we're actually going to use to find the volume, because we know that density is just mass over volume. So if we rearrange this, we get that volume is equal to mass over density. So we're going to take our 124 grams of solution that we found in part A, divide by the density of 1.06 grams per milliliter, and we see that our solution has a volume of 123 milliliters. So converting that to liters, we get 0.123 liters. And our solution then has a molarity of 3.30 molar. So in this case, we're actually able to extend our mass percentage, knowing that with the density, we could use the mass of solution to find the volume of the solution. It is important to keep the context that this density is of the entire solution, it's not of any one component. This is going to be something more important should the context of the problems change. We want to keep in mind exactly what numbers belong to which part of the solution, either the solvent, or the entirety of it. Okay, one more. Where the fuck is my cursor? Bro.